Hello everyone, my name is Parthiv Parik. Today we are going to start JEE numerical practice. Okay, so here one problem that we have given, it is came from the current electricity. Okay, so here we have given three branches. Now from the first branch, current I will be passed, right? And from point P, it will divide into I1 and I2. So according to junction rule, here you can write I is equal to I1 plus I2. Now here you apply Ohm's law, right? Now we know that what is Ohm's law, that is V equals to IR, right? So here you can apply in terms of I, we can write V by R. So here V, the potential that you have given. So here you can write 50 minus, and here is the potential that is P. So here you can write minus P divided by the R is 10 in this branch, and here is I1. So in second branch, the current will pass, that is I1, right? But here you can write the potential, that is P. Initial potential minus final potential is 10 volt. Okay, so here we can write P minus 10 divided by the resistance, that is 5 ohm, plus in third branch the current will pass, that is I2, and the resistance that is given 5 ohm, and the final voltage that is 10 volt. Okay, so initial, that is we can write here P minus final voltage, that is 10 divided by 5 ohm. Now simplify this equation, then we get the answer, the final potential at point P. Okay, it's very easy. Now do it. Now 1 upon 5 is common from the right hand side, and P minus 10, P minus 10. So there is 2 times P minus 10. So here you can write 2P minus 20 directly. Okay, and here is 50 minus P by 10. So here you can cut this 5 to the 10, right? So here you can write 50 minus P is equal to 2P minus 20 multiplied by 2. Okay, so further we can do the calculations and we get the answer, that is 4P minus 40. Okay, now simplify again. So we get the answer, that is 5 plus 40, that is 90, and 4P plus P, that is 5P. So answer P is nothing but is 9P divided by 5, so that is 80. Okay, thank you. Now the second numerical, which is from capacitance chapter. Now there are many capacitors that we have given in the circuit. Now see this two capacitor, which is in series, right? So for series we can write the formula, that is 1 upon C plus 1 upon C1 plus 1 upon C2. So here you can write the solution, that is 1 upon 6 plus 1 upon 6, that is 2 upon 6. But we don't want 1 upon C, we want C only. So again we can reciprocal. So this 6 by 2, it is nothing but this is 3 microfarad. Now this equivalent capacitor, which is parallel to the 3 microfarad capacitor, right? Now for parallel combination, we can write the formula, that is C is equal to C1 plus C2. Okay, so here 3 microfarad is equivalent capacitor, and again that is 3 microfarad capacitor. Both are in parallel. So for parallel we can write, that is 3 plus 3, so 6 microfarad, right? Now this equivalent capacitor, which is parallel, so sorry, series with the 6 microfarad. Okay, so here you can write 6 microfarad. Okay, for parallel connection we can write, that is 1 upon C again, and 1 upon C1 plus 1 upon C2. So here you can write 1 upon 6 plus 1 upon 6. So again it will come 2 by 6, and reciprocal is 6 by 2, that is 3 microfarad, right? Now the holes pull above the capacitor, which is equivalent capacitor, which is parallel to the 2 microfarad capacitor. Okay, so for parallel combination we can write C is equal to C1 plus C2. Okay, so here we can write equivalent capacitor is 3 microfarad and the parallel capacitor, that is 2. So answer is 5 microfarad. Okay, thank you. Now सबसे सस्ता numerical from the capacitance. See, there are 3 capacitors that we have given. We need to find out the equivalent capacitance between point A and B. How can we find out? See here, two line or two connections that were given. Here is A, so here also we can write A, and A is going from this way, so here also we can write A, and B, this is also B, we can write, and B is going from this way, so this point we can write B. Okay, now we drew a 2 point here. Now we do the connection. Okay, see, between A and B point there is a one capacitor. So here you can draw one capacitor. Again, between A and B there is a another capacitor. So draw another capacitor. And again there is a third capacitor between A and B. So again we can draw here the third capacitor. See, all are in series. So here you can write equivalent capacitor formula, that is C1 plus C2 plus C3. But here all capacitance value are same. So here you can write C1 is equal to C2 is equal to C3 is equal to C. So answer is C equivalent, that is C plus C plus C, that is 3C. This is your final answer. Thank you. Okay, students, next numericals. Now see this two capacitor which is not current flow in this two capacitor. So we are not considered this two capacitor. Okay. Now see in above, that is a 3 capacitor which is are in series, because this two capacitor we are sorted, and below there are also 3 capacitor which is are in series. So in series we can apply the formula, that is 1 upon C is equal to 1 upon C1, 1 upon C2 plus 1 upon C3. Now C1, C2, C3, that is 333 microfarad. Okay. So the formula is, that is we need to apply here 1 upon 3 plus 1 upon 3 plus 1 upon 3, we put the value and you get the answer. That is 3 by 3, that is 1 microfarad. Okay. And for below capacitor also connected in series, so here same formula we need to apply. So answer is same, that is 1 microfarad. Now these 3 above capacitor and these 3 below capacitor both are in parallel. Okay, so answer is 1 microfarad plus 1 microfarad, that is 2 microfarad, because these two equivalent capacitor are connected in parallel. So for parallel connection we use the formula, that is C is equal to C1 plus C2. Okay, now C1 is nothing but it is the above equivalent capacitance, and C2 is below equivalent capacitance. Okay, that is CEQ1 and CEQ2. Okay, so similarly you can write, that is C equivalent 1, C equivalent 2, so that is 1 plus 1, 2 microfarad, right? So this is the answer. The capacitance between these two point A and B is 2 microfarad. Thank you.